Besides avoiding meter loading, to properly use a voltmeter, it is important to properly select range settings and observe polarity. Observing range settings is important to keep from damaging a meter and for the greatest accuracy. Voltmeter accuracy is specified as a percentage of the full-scale reading. Typical basic voltmeter accuracy might be 2 to 3%. If this meter was reading 10 volts, the amount of possible error would be determined by multiplying the percent of accuracy times the full-scale reading. Let's assume the accuracy of this meter is 3%. 3% times 10 gives us an accuracy of plus or minus 0.3 volts. The voltage range equals the indicated value plus or minus the possible error value. Therefore, the actual voltage might be anywhere from 9.7 to 10.3 volts. If we were measuring 1 volt on the 10 volt range, the error would still be 3% times the full-scale value. In this case, then, the real measurement might be anywhere from 0.7 volts to 1.3 volts. The amount of error, then, is more significant when measuring 1 volt on the 10 volt range. Whenever possible, therefore, set the range switch on a meter so the pointer indicates as close to full scale as possible so that the error is less significant. You should also observe the range settings on your meter and select a meter with a higher range or full-scale value that is greater than the voltage expected to be measured to protect the meter. If you don't, pegging the meter and possibly damage to the meter can result. If the voltmeter has multiple ranges, start measuring on a high voltage range. Measuring on too low a range will peg the meter. Finally, be sure to observe polarity when measuring voltage. The negative lead, almost always black, is connected to the negative, often the ground connection in a circuit. The positive lead, almost always red, is connected to the positive connection. Reversing the leads causes a downscale indication and may damage the meter.